Okay, now that we've talked about scalars and vectors, it's time to start getting into some specific examples of each. And the first we'll introduce you to is the distance versus displacement. All right, distance, you've probably talked about this before when you say it takes, 30 miles to get to whatever place, things like that. So distance, you're familiar with measuring it in length, all right? So the kind of like SI unit for distance is going to be meters, but it could be measured in centimeters, feet, miles, kilometers, whatever. But distance is a scalar, which means the direction does not matter. The easiest way to think about that is it's the total distance you go. Regardless of if you go north, south, east, and west, it's your total distance, okay? Whereas displacement is a vector, or it's kind of like the change in your distance from start to finish. All right, so displacement again would be meters, the standard SI unit, could also be feet, second, whatever, but it also has to have a direction. Okay, then easy way to kind of distinguish these, distance is total distance regardless of direction. And then thinking displacement, kind of the easiest way is the shortest path from your starting point, from your home point to the end, plus the direction that you go. All right, so we'll do a sample problem so you can kind of see this in action. So, with these sample problems, if you have a feeling like you know what you're doing, pause the video, try it out yourself. If you're not sure what you're doing, and then just watch it all the way through and write down what happens. But really, if you can pause yourself and take care of these before seeing it, then that means you're really understanding it right away. Okay? But this one is kind of a long one, and I'm going to shrink this down so I have somewhere to do my work. All right? But Susie wants to go shopping at Caroline. She gets off at the 101 at Scottsdale Road, and then she drives 3.7 kilometers south along Scottsdale Road to Greenway when she thinks, oh no, I left my wallet at home. So she makes a U-turn, goes back north towards 101. Just before reaching Bell Road, 1.5 kilometers road, Susie sees her Walmart sitting on the passenger seat. At Bell Road, Susie makes another U-turn, returns to Greenway, and goes shopping at Caroline. Starting when Susie gets on Scottsdale, what is Susie's total displacement and total distance and displacement? Okay? So a lot of times with these, it helps if you draw pictures. So let's make this position up here 101. And then we know from there, she's going to go to Greenway. And then somewhere in the middle between those is Bell Road. So here's our picture. And then draw your vectors. Even if you're just solving for distance, start with drawing the vectors. All right. So we have our first one. She drives 3.7 kilometers south along Scottsdale Road to Greenway. So we have this vector where she goes from 101 to Greenway. And we know that's 3.7 kilometers. All right. And then she makes a U-turn and goes north back towards the 101. Just before reaching Bell Road, she sees her wallet. So we go from Greenway to Bell, and that's 1.5 kilometers. Okay, and then lastly, when Susie realized that she actually does still have her wallet, she turns back around and goes the second 1.5 kilometers to Greenway. So there's her vectors. Now, I drew these vectors side by side so it's easier to see, but really what's happening is we have the red vector, which I just drew the wrong way. We have the red vector, and then in the exact same position, we have our blue vector, and then right on top of that, we have our green vector. It's just when you start drawing lines on top of each other, they get hard to see. So I want you to keep in mind we are only dealing with the fact that there's north and south directions here. There was no lateral movement east-west. Okay? So let's start thinking about this. Total distance, does direction matter? Hopefully you are saying no. So to find total distance, we just need to add up all of our distances. So we have 3.7 kilometers. We have 1.5 kilometers plus another 1.5 kilometers. So our total distance equals 6.7 kilometers. Okay? Now, to find our displacement, this is where direction matters. Okay? And if you remember from our videos before, we did say that south or down is negative, up or north is positive. Okay? So for displacement, we have to include those directions. And you have to make things negatives in order to deal with the numbers, and then at the end, if your final answer is negative, then you know you went south, and then at the end, if your final answer is positive, you know you went more north. So we're going to have negative 3.7 kilometers, because that was south, plus 1.5 kilometers positive, missed an M there, because that was north, plus negative 1.5 kilometers, okay, because that was south again. So, looking at our numbers, if we add these together, our positive 1.5 and our negative 1.5, those are going to cancel each other out. So our total displacement is 3.7 kilometers, and because that ended up being a negative sign, that means it was south. Okay? So, distance and displacement, it is best to draw pictures. Distance, you just add the numbers together. Displacement, you're going to have to assign negative numbers if there are changes in directions. Okay?